A VLAN, a virtual local area network, defines a broadcast domain and provides easy management, also provides isolation, as you know, and the different VLANs cannot communicate each other without a layer 3 device such as a router, firewall, or layer 3 capability of switch. By using inter-VLAN routing, you can establish communication between different VLANs with a layer 3 device. Popular methods of the inter-VLAN routing are router on a stick and the layer 3 switching. Router on a stick is a term frequently used to describe a setup that consists of a router and switching connected using one Ethernet link configured as an .1q trunk link. In this method, the switch is configured with multiple VLANs and the router performs all routing between the different networks and VLANs. For this purpose, you create sub-interfaces configured with .1q so they can interact for different per VLAN on the router. As you can see on the router A, we have a physical interface connected to our switch, which is Gig01. This is the physical interface. But what I'm doing in this method, router on a stick method, is I'm creating 1, 2, and 3 sub-interfaces for this example to provide the communication between these 3 different VLANs. Okay, let's go ahead how we can configure a router on a stick. On the switch side, what I'm gonna do is on the related interfaces, I'm assigning my VLANs to the interfaces, as you can see. For example, interface phase 04 will belong to VLAN 10, and the 5 will be belonging to 20, and the other guy 6 will be belonging to VLAN 30. Then the fast Ethernet 01 will be configured as a trunk port because that's gonna carry the VLAN 10, 20, and the plus VLAN 30. What I'm gonna configure on the router side is for router A, I'm gonna create some sub-interfaces, as you can see. To create a sub-interface, the command is interface Gig01, the physical interface, dot the sub-interface's name. This is the sub-interface, the whole thing is the sub-interface, Gig01.10, Gig01.20, Gig01.30. Okay, I'm terminating the VLAN 10, VLAN 20, and VLAN 30 in here, as you can see, but I could do this thing too also, Gig01 dot maybe 15, but if I use again encapsulation.1q10, I will be terminating VLAN 10 again in here. Okay, this number is arbitrary, but for simplicity we are using the VLAN number as the sub-interface name. The thing we need to focus on for terminating VLAN is actually the encapsulation.1q command. Alright, we are getting into the sub-interface mode by typing Gig01.10 in here. Then we are typing the encapsulation, and encapsulation mode will be .1q, and then the VLAN number. Okay, that means we are terminating the VLAN 10 to 20 and the 30 for each subinterface. Okay, then The last thing we are doing in here is we are assigning an IP address for each subinterface. For example, for gig 01.1.10, I'm assigning 1041.10.1. For gig 01.20, I'm assigning 1041.20.1 and 30.1 for the other guy. Okay, what I need to configure on the client side, for example, PC1, PC2, and PC3, I need to configure the subinterface IP addresses as the default gateway of these clients. And, for example, if PC1 wants to communicate with PC2, since they have different network IDs, the packet will be forwarded to the default gateway, which is 10.1, which is this subinterface, then will be forwarded to gig 01.20 subinterface, and packet will come to PC2. To verify the router on a stick configuration, first we can ping host devices from each other. For example, we can ping PC1 from PC2, and we can check a show running config output, and we can check the step-by-step configuration, or we can check just the subinterface configuration by typing show run interface and the subinterface name, or we can check the show interfaces trunk on the switch, and we can see if the link is operating as a trunk or not.